MCP, the Model Context Protocol, creates a direct bridge between AI coding assistants like Claude Code, Cursor, and GitHub Copilot and your Figma designs. Instead of manually describing what a button looks like, your AI can access the design directly. Now, when it comes to connecting Figma with AI agents, there are two fundamental approaches, and understanding the difference is crucial. The first approach uses Figma's REST API. This is what most open-source Figma MCPs use today. Your application makes HTTP requests to Figma's servers over the internet, fetches the design data, and passes it to your AI agent. The second approach uses Figma's plugin API. This is what Figma's official MCP uses, and it's the same API that powers every plugin you see in Figma. Instead of going through external servers, it runs locally inside your Figma desktop app. So what's the practical difference? First, there are rate limits. According to Figma's documentation, users with View or Collab seats are limited to just 6 requests per month for file content endpoints. Second, context richness. The REST API returns a JSON representation of your file, which is comprehensive, but it's also massive. Even a simple page can generate megabytes of data. And here's the thing, while the REST API gives you access to the design structure, it doesn't provide the same level of real-time, in-context data that the plugin API can access. Third, latency. Every request goes over the internet to Figma's servers and back. For complex workflows where you're iterating quickly, those round trips add up. This brings us to the plugin API approach, and this is where things get interesting. When you use the plugin API, everything runs locally on your machine. The plugin sits inside your Figma web or desktop app, has direct access to the design context, and communicates with your AI agent through a local server, typically over localhost. The benefits: unlimited usage. No monthly request limits. Richer context because you're accessing the same APIs that Figma's own features use. Lower latency since nothing's going over the internet. And all your design data stays on your machine, there's no data leaving your local environment. Even plugin API-based MCPs face a critical issue: Figma's design data is massive. A single page can consume 70 to 80% of your AI agent's context window. Most open-source MCPs, whether REST or plugin API, make the same mistake: they pass raw or minimally processed Figma data directly to the AI. The result? Overwhelmed agents, degraded performance, and inconsistent outputs. The solution isn't more access, it's intelligent preprocessing. You need to distill massive Figma structures down to only the design information that matters, without losing critical details. And that's exactly the problem Zapcode was built to solve. Zapcode is a plugin API-based MCP that processes Figma data intelligently. It analyzes your design, strips out redundant information, optimizes the structure, and delivers a compressed representation that typically uses only 10 to 20% of your AI agent's context window. Free for 5 uses per day, with affordable credits beyond that. Works with Claude Code, Cursor, GitHub Copilot, and other MCP-compatible tools. All data stays local on your machine. And it's been tested on hundreds of real-world wireframes to ensure that 99% of designs are processed accurately. Let me show you how it works. Let's start with installation. Open Figma, and in the bottom menu you'll find the Resources button. Click on it, and you'll see a search bar. Type Zapcode, and the plugin will appear. You can also find it by searching Zapcode Figma in Google. The first result will take you directly to the plugin page. Click on the plugin and press Run. You'll be presented with a login screen. If you don't have an account, you can sign up here. Since I already have an account, I'll simply sign in. Perfect, we're on the home page. Notice the MCP status shows as disconnected. That's because we haven't configured our MCP client yet. Let's fix that. Click on this Connect button, and it opens the MCP port management page. This is where you can add multiple ports to connect different MCP clients or different projects within the same client. For example, if you're working on several projects in Claude Code simultaneously, you can configure separate ports for each. Let's add a new port. I'll name this one Claude Code Demo. You can add project names or whatever helps you recognize the port later. I'll select port 32896. Now I'll add the port and try to connect. After a few seconds, it will fail, and that's expected since we haven't configured Claude Code yet. But notice what happens. The plugin displays an error message with the exact configuration you need. You can copy this configuration directly and add it to your MCP client. There's also a simpler way to configure this. Zapcode provides a one-line command you can run. I'll copy this from the website, come back to my CLI, and paste it here. The important thing is to make sure the port number matches, in our case, 32896. Press enter, and that's it. Your MCP server is configured. Now when I run Claude Code, we can confirm the MCP is configured and available. Now, one important thing to keep in mind, if you're working with multiple VS Code windows running Claude Code, make sure each project has a unique port number. Here's what can happen: if you have 2 or 3 VS Code windows open, and some of them share the same port configuration, the plugin might connect to a different window than the one you're actively working in. The plugin UI will show connected, but you won't see which specific client it's connected to. If you encounter errors saying Figma plugin not connected, close all other instances of Claude Code and keep only your active project running. This ensures the plugin connects to the right workspace. Now, I'm going to create a Vite-based React app, add the necessary dependencies, and run the local server to make sure everything's working. While that's loading, let's come back to Figma. I'll select the page I want to generate code for. In the plugin, there's a tech stack settings option. Here you can choose different frameworks: Angular, React, Next.js, and others. Since Claude Code already has context about my project and knows I'm using React, I'll go with Figma context only. If you choose other options, additional best practices prompts will be attached along with Figma's design data to help the AI do a better job. I'll save these settings. Notice the plugin now says, component selected, it's ready to send this design data to Claude. Coming back to Claude, I'll ask it to create a landing page using the Figma screen I've selected. Claude will request permission to use the tool, just like any other MCP client. You'll press yes to approve. And there we go, the design data is now in Claude's context. I'll let Claude work through this, and we'll check back in a few minutes. Okay, we're back. Claude has generated a complete plan, breaking the page into different components. For demo purposes, I'm generating the whole page at once, but in practice, you'll get better results by working on individual components, like the hero section, or complex elements like calendars, then bringing them together using the full page as reference. Let's let Claude continue working. One thing you might notice, Claude sometimes starts generating back-end code along with the UI. For this demo, we only want UI generation with mock data, so I'll redirect it to focus just on that. Alright, let's open the browser and see what we have. As you can see, because we gave Claude the entire page at once, the results aren't as precise as they could be. This is where component-by-component refinement comes in. Let's focus on specific sections and improve them. I'll come back to Figma and select just the header component. Then in Claude, I'll ask it to refine the header using the latest data from Figma. Notice I'm saying, from Figma, explicitly. This tells Claude to pull fresh design data using the MCP. Even though the design hasn't changed, when Claude focuses on a single component, it does a significantly better job. Perfect. Look at the header now, it's matching the Figma design much more accurately. We can even see some responsiveness working. Let me do the same thing for the hero section. I'll select it in Figma, then ask Claude to improve it using the Figma design. Notice that Claude only pulls the hero component data this time. It's now laser-focused on just this section. Speaking of responsiveness, it's also possible to address different viewport sizes using this MCP. If you have mobile or tablet designs in Figma, you can select those and provide that context to Claude. Just a useful trick to keep in mind. Excellent. The hero section is much closer to the design now. One element that's still missing is the calendar component. Let me ask Claude to add that. I will select the calendar component on Figma. Claude didn't need to pull Figma data this time since it already created the calendar component from the initial page generation, it's just importing what it built earlier. But if you wanted, you could select the calendar specifically in Figma and have Claude refocus on it for even better accuracy. And there we have it, a complete landing page generated in React in about 20 to 40 minutes using Zapcode MCP. Each time your AI agent requests design data, it costs 1 credit. You get 5 free credits every day, and you can purchase more if needed. The free credits are always used first, even if you have purchased credits available, so you continue getting your daily free usage regardless. That's Zapcode Figma MCP. If you found this helpful, the links are in the description. Thanks for watching.